In this video, I'll be going over Assignment 10, Part B, which is the coding part to Exercise 5.42 in the textbook, which is Enforcing Privacy with Cryptography. It says the explosive growth of internet communications and data storage on internet-connected computers has greatly increased privacy concerns. The field of cryptography is concerned with coding data to make it difficult for unauthorized users to read. In this exercise, you'll investigate a simple scheme for encrypting and decrypting data. A company that wants to send data over the internet has asked you to write a program that will encrypt it so that it may be transmitted more securely. All the data is transmitted as 4-digit integers. Your app should read a 4-digit integer entered by the user and encrypt it as follows. Replace each digit with the result of adding 7 to the digit and getting the remainder after dividing the new value by 10. Then swap the first digit with the third and swap the second digit with the fourth. Then display the encrypted integer. Write a separate app that inputs an encrypted 4-digit integer and decrypts it by reversing the encryption scheme to the original number. Use the format specifier D4 to display the encrypted value in case the number starts with a 0. The format specifier D is used to format integer values, and D4 indicates that the value should be formatted with a minimum of 4-digit positions, possibly leading with zeros. Okay, so we're going to open our Visual Studio and we're going to create a new app. Just like we've been doing with the previous exercises, we're going to use the using directive of system. We're going to create a class, and I'm going to call this class Cryptography, since that is what we're learning in this assignment. Sorry, let me get that out of there. And we're going to give it an opening and closing curly brace. And within the class, we're going to have a main method with not taking any parameters or arguments. And then within the main method, or actually, we are going to have another method outside of the main method. So we're going to create a method to encrypt the user input. And then we're also going to create a method, again this is outside the main method, to decrypt the user input. Now this can be done in 2 separate apps, but just for the sake of time, I'm going to do it all within the one same app. So within the main method, we are going to, it says your app should read a 4-digit integer entered by the user and encrypt it as follows. So first we'll need to prompt the user to enter a 4-digit integer. And we know how to do this with a console.writeLine. I'm trying to do this pretty quick because this is stuff we should already know. Okay, enter a 4-digit number, or you can say whatever you want. Please enter a 4-digit number, enter a 4-digit integer, whole number, whatever you want. Okay, so we're going to prompt it, and then we're going to read the user input and convert it to an integer. And we should know how to do this by, let's call this variable number. So we'll know that's the number that the user input. We know how to do this already. We should know how to do this already by int.parse, right? And that's parsing or converting the user input into an integer. And how we get the user input is by a read line. So that way the app or the program is reading this line that's input by the user. Okay, again, we should definitely know this by now. So what we've done so far is your app should read a 4-digit integer entered by the user. Okay, so now it says, and encrypt it as follows. So now we have the prompt from the user and it's reading it. Now we're going to go down to our we have two methods that we're going to create here. This one is the method to encrypt it. So this is what we're going to create right now, is a method to encrypt the user input. And this will be, so we're going to create a static method. This will be static. Okay, we're going to create a static method with user input, and we're going to also, this method will take a parameter. So I will say with a parameter of number of the number variable. So this is taking the parameter of the user input read as an integer, which we've assigned to the variable number. So this will take the parameter of that variable number. Okay, so because it's a static method, we're going to do it the same as we do the made method, except it will have a parameter. So static, and then this is int for integer. So here in the main method, it's static void. We're not voiding it. We are giving it, we are going to make sure it's read and stored as an integer or whole number. And let's call this encrypt number. And then again, we're going to be we are using the parameter of number with type of int. So we're going to go ahead and say this parameter has a type of int, and the parameter we're using is we're calling the variable that we've created up there that we've called number. Okay, and then we use opening and closing curly braces because it's a method. Okay, so this is, I'm basically putting a note on here to say this curly brace is for the end of this method. So anything between these curly braces is going to be a part of that method. Okay, so now the first thing we're going to want to do to encrypt the number is we're going to need to extract the, let's see, the digit. We're going to need to extract the individual digits from the user input of the variable number. Okay, and this is something we have also done where we need to use just a little bit of math. So for getting the digit for the 1,000, okay, so number 1 through a number with 4 digits is has a value of, it has a thousands place, a hundred place, a tens place, and a ones place. So let's say get digit for thousands place. And then, well, actually, we're not getting it, we're extracting it, right? Extract digit from thousands place. Okay, let's just copy this, save a little bit of time. Except now it will be hundreds and tens and ones place. Okay, so we're gonna extract the individual digits from the number, and first we're going to extract the digit for the thousands place, and by how we're going to do that is by dividing by 1,000. Okay, divide the input from the user that we've stored under the variable number, divide number by 1000, and because if you divide it by 1000, the decimal would go right here. Oops. And so the only whole number left is that thousands place number. So divide number by the 1000 will give you the digit for the thousands place. So we're just going to do that for digit 1. We're going to read and store as an integer, and we're initiating. Okay, it's not just storing it, reading and storing it. We're going to initiate it as an integer, and we're going to initiate it and give it the name of digit 1, and we're going to give it the value of number. That's our variable that we've used to store the user input that we're reading as an integer. Number divided by 1000, and that will give us the thousands place, the single digit for the thousands place number. Okay, now extract the digit for the hundreds place will be just a little bit different. So it will be, we'll need to divide the number by 100, but that would give us the value. Okay, so let's say, oops, let's say we have an example of 1, 2, 3, 4. That's the digit we're going to use. Okay, so for here, the thousands place would be divided by 1000 equals 1.234. The integer, or the whole number, is 1. Okay, so for the hundreds place, if we divide by 100, the integer will be, okay, if we divide by 100, the integer would be, it would be, divided by 100 would be 12.34. So the integer would be 12. So that does not give us a single digit of 2 that we're looking for. So we have to then get the remainder. So we can't just divide by 100. Here, let me do this on a different line. Okay, so we can't just divide by 100. We have to take the remainder by 10, or get the remainder of the number divided by 100. Okay, divide that by 10 and give me only that one digit of the remainder. So 12.34 divided by 10 is 1.234. So the remainder is 2, because right here 12.34, then you divide it by 10, so you go over one decimal place value, you move the decimal one place value, and where the number that it skipped over there is the number 2. That's your remainder. So the remainder would be number 2. So divide by 100 and take the remainder by 10, which means divide by 10 and get just the remainder. Okay. All right, so we're going to write that here as int digit 2, assign it the value of, and again, what we're dividing by 2 is the variable of number. That was the user input that we're reading and storing as an integer. Okay, and then we're going to take that variable of number, the user input, divided by 100, and then get the remainder of this divided by 10. Okay, and we're going to do the same thing for the tens place. Okay, so extract the digit for the tens place. it easier to read. Okay, for the tens place, we're going to do the same thing. We're going to divide by 10 because we want the tens place, not 100, and take the remainder by 10. And it has the same logic as digit 2 here, dividing by 100, except we're looking for the tens place, and that's why we're divided by 10. So in our example, of 1, 2, 3, 4 divided by 10 would be equal to 123.4. Okay, and then divided by 10 again, we get 12.34. So the remainder is 3. So we're getting that single digit of 3. All right. So we're going to do initiate an integer that we're calling digit 2, and we're going to assign it the value of the variable number divided by 10, because we're getting the tens place, and we want to take the remainder by 10. I do not want these tabs, so oops, this is digit 3. Sorry, because this is the tens place digit. All right, now for the final digit, it'll just be slightly different. Let's get rid of this extra stuff. Okay, extract the digit for the ones place. Since it's the ones place, we don't need to divide it by anything. We could divide it by 1, but that's just it in and itself, so we don't need to divide it by anything. All we have to do is take the remainder by 10. So in our example of 1, 2, 3, 4, we don't divide it by anything, but we are going to get the remainder of it divided by 10. So we're going to get the remainder of 1, 2, 3, 4 divided by 10, which is 123.4. And so the remainder is 4. So 1234.0, it's not reading anything on this side because it's only reading the whole number. So when you move the decimal place over one digit, that digit that you're extracting here is the digit of 4, or the remainder of 4. And that's the digit that we're extracting. So we're going to go ahead and initialize this as digit 4 as an integer, and we're going to say number, because that's the variable that we're using, and then we're taking the remainder by 10. Okay, so that's how you extract each digit. So now we have one digit for digit 1, which will be the digit that is currently in the thousandths place, and then digit 2, which is currently in the place of the hundredths place, digit 3. Okay, so now we've extracted those digits, so they're all a separate digit. Digit 1 is just equal to 1, or whatever the user input. It's only equal to that one single digit. It's not equal to a thousandths place. Okay, so now we've extracted the individual digits from number. Okay, now we want to encrypt the digits. Okay, and we're going to do that by, it says, encrypt it as follows. Replace each digit with the result of adding 7 to the digit and getting the remainder after dividing the new value by 10, or taking the remainder by 10. So add 7 and take the remainder by 10. And then we'll do something else next, but we're going to worry about this part right now. Add 7 and take the remainder by 10. So we are going to do that for every individual digit that we've just extracted. So we are going to encrypt the digits by adding 7 and take the remainder by 10. Okay, and we're going to do this to all of the digits. So we'll start by getting the variable that we've created up here of digit 1. So we're going to type digit 1, and then we're going to give that the value of digit 1 plus 7. That's how we're adding 7. Okay, and then we're going to take the remainder by 10. Okay, so this is what it will look like for each digit. So it'll be digit 1 now has the, we're assigning the value of digit 1 plus 7. So remember, we're adding 7 and take the remainder by 10. Adding 7 and take the remainder by 10. And we'll do the same thing for each digit. Okay, so we have digit 1, 2, 3, and 4, and we added 7 and take the remainder by 10. So in our example of 1, 2, 3, 4, if we, let's see, our digit 1 is, let's see, okay, so in our example 1, 2, 3, 4, our digit 1 has the value of 1. So 1 plus 7 is 8, and then we want just the whole number of that, so we're going to divide it by 10, which makes it 0.8, and so the remainder is that 0.8, which will give us the value of 8. So let's say, so we know that 0.8, so 8 divided by 10 is 0.8, but since we're getting just the value of that remainder there, the value will be 8. We're going to do that for each one. And the reason we're not just adding 10, just adding 7, is because it could be like 9 plus 7 is not going to give you a single digit for the whole number. Like 9 plus 7 will be 16. So you divide that by 10 would be 1.6. So what you'd be getting would be 6. So it would be totally different. So right now, because we're using 1, 2, 3, 4, it kind of seems like, what is the point of dividing it by 10 and getting the remainder? But if you were to use a different number, you would see how the different results are. So, okay, digit 2 plus 7 is 9. So we know it'll be 9. But if we didn't, we'll do the math, and we knew it was 0.9. And then 3 plus 7 is 10. So 10 would be, actually, 3 plus 7 is 10. 10 divided by 10 is 1. So the remainder, so this would be 1.0. Okay, the remainder is 0. So the number that we're getting there is 0. So Okay, so if you see over here, the remainder that we're getting is the 0. So here the remainder is 8, remainder 9, remainder is 0. Okay, now again, this is, in our example, this would be number 4. 7 plus 4 is 11. So it would be, oh my goodness. So 11 divided by 10 would be 1.1, with the remainder being 1. So let's move all these over like 2 spaces. Okay, so you can see here the remainder is that first number after the decimal. Those are the remainders that we're taking in. So with 1, it becomes 8. With 2, then the remainder that we're getting, it becomes 9. With 3, it will be 0. With 4, will now be 1. So these are the new values that we've given for the encryption that we were told how to encrypt it by first adding 7 to the digit and getting the remainder after dividing the new value by 10. Okay, so then the next thing we want to do is, it says then swap the first digit with the third and swap the second digit with the fourth. So the next thing we want to do is swap the digits, and it says swap first digit with the third, and then swap the second digit with the fourth. Okay, so in order to swap the first digit with a third, we are going to first need, or we're going to create a variable to store the original value of digit 1, or of the first digit, okay? And we're doing that because when we assign the value of the first digit to the value to the third digit, we don't want to swap the newly created value of the first digit. We want to swap the original value. So we're going to go ahead and say we're going to initiate a variable that we're going to call temp, and that will be a variable with the type of integer. Okay, and we're going to give that the value of digit 1, because that's what we want to store in that value, and that variable is digit 1. And then we're going to assign the value of digit 3, oh my goodness, to digit 1. So now digit 1 has the value of digit 3. So now if we go ahead and enter the value of, oh my goodness. Okay, for digit 3, if we want to assign it the value of digit 1, we're not going to assign it the value of digit 1. We're going to assign the value of temp, because that is storing the original value of digit 1. If we assigned digit 3 the value of digit 1, it's going to give the same value as digit 3. It's not going to work. So we're going to give it the value of temp. Oh my goodness. Okay, so this is swap digit, oh my goodness, 1 with digit 3. And then this is swap digit 3 with the original value of digit 1, not the newly created value. Okay, so we're going to do the same thing. Oops. We're going to do the same thing to swap the second digit with the fourth. We're going to use the variable temp, or we're going to assign it the value of digit 2. And we are going to say digit 2, we're going to assign the value of digit 4. And then digit 4, we're going to assign the value of the original value of digit 2. So store the original value of digit 2 in a variable, and then swap digit 2 with digit 4. And this is actually replace. We're replacing. Replace. And then we're going to replace digit 4 with the original value of digit 2. Okay, so now we've swapped 1 for 3 and 2 for 4. All right, now it says, then display the encrypted integer. So in order to display it, that will be back up here in our main method. Okay, but in order to display it first, we need to return it. Return, let's see, the value of where is it? Okay, so we'll return the value of encrypted number. So we'll say return okay, so actually before we return anything, we need to actually reconstruct the encrypted number with the swapped digit. So we have to, so now we have the individual digits and we've replaced their value, but we actually haven't constructed the number to have a value places. So we just have 4 digits. We can't return those 4 digits until we've given them place values to know how to return it. So first we're going to let's say reconstruct the encrypted number with the swap digits okay, so we want to give the new we want to give the numbers that we've replaced a new place value. So we're going to reconstruct the encrypted number with the swap digits to give the numbers the new place value. Okay, reconstruct number with swapped to give the numbers a new place value. Okay, and we're going to use this by initializing a variable with type of int, and I'll just call the variable encrypt, and we're going to say we're going to assign it the value of digit 1. We're going to say times 1000, because that will give it the thousands place value. So digit 1, whatever that might be, is now going to be in this place value. And we're going to do the same for all the digits. So digit 2 will be multiplied by 100 to get the 100's place value. And we're adding the plus sign in between. We're adding all these. So this plus this number plus this number. So this is the thousands place digit. This is the hundreds place digit. Next will be the tens place digit. So multiply by 10. And then finally we'll have the ones place digit, which we don't need to multiply it by anything. We're just adding that to the end. With the semicolon. Okay, so to give them each their place value, we're going to multiply. So digit 1, in order to put that in the place of the thousands place value, we're multiplying by 1000. Digit 2 by 100, digit 3 by 10, and digit 4 just is there by itself, read as a whole number with the value of it, the number itself. So this will be the ones place, tens place, hundreds place, thousands place. Okay, and then we're going to return this variable that we've just created. Okay, so that looks good. So now we're going to come up here and we're going to say, let's see, how do we want it to? So we're going to have to create another variable. Actually, we're going to initialize the variable. That's going to call, okay. Initialize a variable and assign it the value of the outcome of the encrypt number method. And then it will also take a parameter of this variable here that is number, because we're going to use the original input from the user and that's what it will be initializing the method with this given number. Okay, so we will write int encrypt and then give it the value of the encrypt number method with the parameter of number. So this is our variable that we're going to use in order to display that to the console. So display encrypted number to the console. And we do that, of course, by console.writeLine. Okay. But we will be using string interpolation because we are going to be including this variable, but we're also going to be using the format specifier of D4. So it says use the format specifier of D4 to display the encrypted value in case the number starts with 0. So that's why we'll be using that D4. It says the format specifier D is used to format integer values, and D4 indicates that the value should be formatted with a minimum of 4-digit positions, possibly with leading zeros. So we are going to write like encrypted number, and then we're going to display the encrypted number by using the curly braces. And I have a space here in between so that when it displays to the console, you'll see that space. So we're going to use the curly braces here, and inside the curly braces, we're going to call this variable that we just created right here of encrypt. Okay, and that's where we're going to use right here the format specifier D4, which means we're just going to write a colon D4. That's how we do that. So now if we go ahead and check our app, it should be able to encrypt the number. So let's use our example, and it says encrypted number 0189. So it looks like it worked. Let's check our numbers here. These are the numbers that we had before we changed their positions. So it looks like the numbers are there. But we're going to replace digit 1 with digit 3. So this will be, let's write that here, digit 1 with digit 3. So digit 3 should be 0. And then replace digit 3 with the original value of digit 1, which should be 8. So, okay, actually, let's just write it down here. So 0 and 8. And then digit 2 and digit 4 should be, so replace digit 2 with digit 4. So digit 4 should be 1. And digit 4 should now be digit 2 of 9. So it should be digit 1 is 0, digit 2 is 1, digit 3 is 8, and digit 4 is 9. And then it should read them as not just these digits, but 0, 1, 8, 9. So let's see, is that what it did? 1, 2, 3, 4, 0, 1, 8, 9. So everything looks good. The only thing is, because we have all this extra stuff written on there that we can see, we want to exit the program so that it doesn't have all that extra stuff on there. So we're just gonna add an empty, read line, not write line, so that it won't close until the user presses enter. All right, so that's how you do the first app of encrypting the number. Now we have to create a method to decrypt it. All right, so in order to decrypt the number, we have to create a method. So the method will be the same as the encrypt method. It will be a static method, and it will have the type of integer, and we'll call it decrypt number, because this one is when we're decrypting the number. And we have opening, closing curly braces, and within the curly braces is our method. So we're going to have decrypt number. We are also going to we're going to be using the parameter of the encrypted number. So of this, what we've returned here for encrypt, and we've assigned up here for encrypt, that's what we're going to be using. We're going to be using this from the main method, because this static method, we're not taking anything from this encrypt number method. We're taking it from what we've declared up here in the main method. So we're going to use encrypt as a variable. So, as a parameter. So we're going to use the parameter, parameter of encrypt and that will have a type of int. So first we're going to type the keyword of int, because we know it has a type of int, and then we're going to say encrypt, so that's what the parameter that we're using. So that's how we do that. And now inside the method, we're going to extract the individual digits, this time not from the number that the user input, but from this encrypted number. So which we gave the variable of encrypt here. So we will be so extract the individual numbers, or individual digits, from the encrypted number, or the encrypt variable. Okay, so how we will do this is the same way that we did when we were encrypting it. So divided by 1,000 will give us the thousands place. We'll extract the digit in the thousands place, just like before. But what are we divided by 1,000? We're not dividing number by 1,000. We're dividing the encrypted number by 1,000. So we're going to initialize a variable called digit with the type integer, and we're going to take the encrypt variable and divide that by 1,000. And then we're going to extract hundreds place, extract the digit in the in the hundreds place. We're going to do that by digit 2. We're going to assign the value of encrypt divided by 100. But remember, encrypt divided by 100 will not give us a single digit in this case, because there's 4 numbers. It will give us 2 digits. So in order to get that second digit, we're going to have to first divide by 100 and then take the remainder by 10. So extract the digit in the hundreds place by dividing by 100 and taking the remainder by 10. to give us that one digit that we're looking for. So extract the digit in the hundreds place by dividing by 100 and taking the remainder by 10. Now, to get the tens place, we're going to do the same thing. We're going to assign it the value of encrypt divided by 10 because we want the tens place. And we're going to take the remainder by 10. So, and this is extract the digits in the tens place. And again, we just did it that same way. All right, so now for digit 4, we are going to not divide it first, but we're just going to be taking the remainder by 10 because it's already in the ones place, and so that's what being an integer will only give the whole number, so we don't need to divide it by 1 because that'll just give it itself. So we're going to encrypt. We're going to use the encrypt, and we're just going to take the remainder by 10, and that will give us the value. That will give us the digit in the ones place. Okay, so hopefully that makes sense by now. We've done it twice on here. We've done it in earlier assignments as well. So that should make sense how to extract each number or each digit by its place value. Okay, so now we've extracted the individual digits from the encrypted number. Now we need to do something with those extracted digits, and what we're going to do is we're going to give them the right in. Okay, so we're going to reverse the encryption. To decrypt it, we need to reverse the encryption. So we're going to reverse what we did by adding 7. And how we're going to reverse it is by, so we will need to, because what we did was we added 7, we're going to need to subtract 7. So we're going to subtract the extracted digit, subtract 7 from the extracted digit, because that's what we originally did, was add 7. And we're going to take the remainder by 10. And the reason we're still doing that we did when we encrypted it, is because we still need just that single digit value. So we're taking the remainder by 10 to get that single digit. Okay, we're not doing anything to make that digit different. But we're going to subtract 7 from the extracted digit, but we're also going to add 10. And why we're adding 10 is so that it becomes, or so that we can't get any negative numbers. Okay, so we'll say digit 1. We're going to now assign the value of digit 1. Oh my goodness. Digit 1 minus 7, and then adding 10 to make sure that it won't be a negative number, and then we're going to take the remainder by 10, and we're going to do the same. We're going to do the same for all of them. So subtract 7 and take the remainder by 10, but by adding 10, before taking the remainder, we ensure that the result is going to be positive. Even if the digit was less than 7, so like if the digit was less than 7 and we subtracted 7, it's just going to be a negative number, and we don't want that, so we're adding 10. Okay, and we're going to do the same thing to all of them. So we're going to do digit 2, digit 3, and digit 4. So we'll do digit 2 is equal to digit 2 minus 7 plus 10. Digit 3 and digit 4. They'll all be the same. And the reason I didn't do, so I did, oops, this is what I want, digit 1. There we go. Okay, the reason I didn't just do, so if you subtract 7 and add 10, you're really just adding 3. But the reason that I didn't write just plus 3 is just so that you can see, so that we can see what we're doing, that we're subtracting the 7 just like we added the 7. Okay, so now we've reversed the encryption scheme that we've created in the encrypt method. But now we need to swap them back to their original place. Swap the digits back to their original place value. Actually no. We're swapping the digits back to their original digit value. Because we actually we haven't done the place value yet. So we will also do that. We'll reconstruct the original number. So we'll reconstruct the original number and give the digits, oh my god, their original, oh my goodness, place value. Okay, so we're gonna swap the digits back to their original digit, and then we're going to give them their original place value. So in order to swap the digits back, we need to swap, swap the first digit with the third and the second with the fourth. We need to do the same thing that we did in the encrypt method right here. So we're going to do the same thing where we're going to create a variable to store the value of the first digit, right? So we're just going to go ahead and copy that right here. We're going to do the same thing. We're swapping them back now. So we need temp for digit 1. Swap the first digit and the third. This is how we do it, remember? So now, we don't need this example there. We're not using that right now. We already know that it should work. So we'll first okay, so we're going to swap the digits back to their original digit by swapping the first digit with the third digit, and then creating a variable to store that original value of the first digit. And then we're going to do the same with the swapping the digit 2 and 4. We're going to swap the second digit with the fourth by first storing the original value of digit 2 in a separate variable. And then we're going to replace digit 2 with digit 4. We replace 4 with the original digit 2, which is temp. Okay, so now we need to reconstruct the original number and give the digits their original place value. And we're going to do this by creating a variable. So we'll create a variable and assign each digit, and assign each digit to the correct place value. And I'm probably not wording that great, but all right, so this will be initialized with the type of integer, and we'll call this original number, because this is how we're going to get the original number. We're going to assign the individual digits, so digit 1, and we're going to give that the place value of the thousandths place value by multiplying it by 1,000. And then we're going to add the value of digit 2, because remember right now that's only a single digit. And we're going to multiply that by 100 to get that in the hundredths digit. And then we're going to add the digit 3 by multiplying that by 10 to put that in the tens place. And then digit 4 we're just going to add because it's already in the ones place. So digit 1, that's just a single digit, is now going to hold the place of the thousandths place. So digit 1 will be in this place. Digit 2, the same thing with the hundredths place. Digit 3 with the tens place, and digit 4 with the ones place. Okay, and now in this method, we have to return the original number. We do that by typing return, and then this variable that we've created here, original number, because this is what has all the digits with their place values stored in there. Okay, so now the decrypt method should be, the decrypt number method should work correctly. We just have to display it to the console. So first we have to, within the main method, we have to call this decrypt number method and get that original number. So what we have to do is we have to initialize a new variable. So same as we did here, but we're going to like the same as we did here. We're going to initialize a variable and assign it the value of decrypt number method. So the variable we'll call decrypt and assign it the value of encrypt number method. But we're going to take the variable, instead of number, we're not going to use the original number that the user input. We're trying to decrypt the encrypted number. Oops, this is not what we want. We do not want encrypt number, we want decrypt number. Decrypt number. And then we want, okay, so, oops, not display. Initialize a variable and assign it the value of decrypt number method. And take the parameter of not number, but encrypt. Because encrypt is this right here, where we're taking that value of the encrypted number with the user input number. So we're not trying to decrypt the original number up here, we're trying to decrypt the encrypted number, which is taking the variable of encrypt. Right? And then we're going to display the decrypted number to the console. And we're going to do this by using the D4, the specifier D4, because once again, it's used to make sure that it is 4 digits and it can start with the number of 0. Use the format specifier D4. So to display the console is actually obviously console.WriteLine, or just console.write if you don't want it to go on another line. So console.WriteLine, we're going to use string interpolation just like we did before, and within it we're going to say decrypted number. And we're going to use the curly braces as a placeholder to enter this variable right here, decrypt, and then we're going to add a colon D4, and of course we'll do the semicolon after. Alright, so now let's see how that's working now, if it's correct. I spelled that wrong. Okay, 1, 2, 3, 4 for our example. And you can see it encrypted the number just like we thought it would, which we've already checked. And the decrypted number is 1, 2, 3, 4. Now I am going to fix the spelling error here. Okay, so that's how you do, that's how you do both those apps. I did them again within the same app. You could do 2 apps within the same file, but a little bit differently, or you can just do 2 separate apps. I just did it within the same file to save a little bit of time because it's already takes so long to explain this in the first place. So again, in our console, we have you enter your 4-digit number of 1, 2, 3, 4, or whatever the user inputs, right? So it'll be different for whatever input, but just because this is what we did in our example, we'll know whether it's correct or not. So enter a 4-digit number, and then it shows the encrypted number, and then we're able to decrypt that number. Okay? So hopefully this made some kind of sense and helped you a little bit. Always remember to save, and we're going to save all, and then that's it. I hope this helped you guys.